Students, we are asked to solve this question. 2x positive 3y dx positive y negative x times dy equal to 0. I will just keep y negative x times dy on the left and move the other quantities onto the right. So that's going to be negative of 2x positive 3y times dx. Then I will move dx down and move y negative x to the right. So that's going to be negative of 2x positive 3y divided by y negative x. Now, if I were to take a negative sign out of the denominator, so that's going to be negative of x negative y. So these two negatives can be cancelled. So I would now have a positive quantity on the numerator and as well as on the denominator. So of course this is a homogeneous differential equation. There's no doubt about that. So now I am rewriting dy over dx as 2 times x positive 3y divided by x negative y. Now what I'm going to do, I'm going to be substituting y to be equal to vx and then differentiating both sides with respect to x. So we get, this is going to be dy over dx is equal to v positive x times dv over dx. Now in place of dy over dx I would be substituting this quantity, so that's going to be v positive x times dv over dx is equal to 2 times x positive 3 times, in place of y substitute vx divided by x negative, in place of y I substitute vx. This is going to be, with x as a common factor being taken out, I would have 2 positive 3 times v divided by x of 1 negative v. Now clearly the x's can be cancelled. Now the v that you see here can be moved. So if I were to move this to the right side, then I would have x times dv over dx to be equal to 2 positive 3v divided by 1 negative v negative v. Now if I were to take the LCM as 1 negative v, I would get 2 positive 3v negative v of 1 negative v, which can be rewritten as 2 positive 3v negative v positive v squared divided by 1 negative v. This is equal to, now 2, I have got nothing to do with 2, but 3v negative v would give me positive 2v followed by v squared divided by 1 negative v. Now on the left I've got x times dv divided by dx. Now if I were to rearrange by variable separable, then I would have 1 negative v times dv divided by 2 positive 2v positive v squared is equal to dx divided by x. Now the question is, can I rearrange the quantities? Okay, can I rearrange the quantities? So how would I do that? Well, now consider the denominator. Now if I were to make this substitution, say let 2 positive 2v positive v squared be equal to sum t. If I differentiate, I get 2 positive 2 times v times dv should be equal to dt. But the numerator does not have 2v. It's just got a negative v and a 1. So I have to do something so that I'm able to get a 2 and a 2v there. Now of course I can take a negative sign out, so that would make v to be as positive. So I would now have v negative 1 times dv divided by 2 positive 2v positive v squared is equal to dx divided by x. So now what I'm going to do is, I need to somehow have this 2 there. So the best way to do that is to multiply and divide by 2. So what I'm going to do, I'm going to have 2 in the denominator and 2 in the numerator. So let me just place 2 like that. So now I can rewrite this as negative, I'm moving this 2 inside, so that's going to be 2v followed by a negative 2, right, times dv divided by 2 times of 2 positive 2v positive v squared. So this is what I have got. Now still I did not. Now the only way I can make or I can have a positive 2 is to add a positive 2 and subtract a positive 2. Okay, of course there is a negative 2 there, so place it. So in this fashion, clearly my objective of having a positive 2 is achieved. Of course there's a negative sign there. Now the question is, we have to rewrite this term again. So what I'm going to do, I'm going to have 2v with a 2, okay, and then negative 4. Okay, I'm going to rewrite it in this fashion, divided by 2 times 2 positive 2v positive v squared is equal to dx divided by x. So this is the way I'm representing. Now this term, I'm going to use some algebra. Now a negative b divided by, say, some d, I can rewrite it as a over d negative b over d. Okay, so that would mean I can now rewrite this entire quantity as negative of 2v positive 2 times dv divided by the denominator 2 of 2 positive 2v positive v squared. So this is one term. Okay, of course there's a negative sign, that's why I'm placing the negative sign there. So followed by negative of 4 over 2 of 2 positive 2v positive v squared times dv is equal to dx divided by x. So this is the representation. Okay, now of course the 2 are featured here, so I can just simply take the 2 out as a common factor and rewrite it as 1 over 2 with a negative sign 2v positive 2 times dv divided by 2 positive 2v positive v squared negative 4 times dv divided by, now we got 2 positive 2v positive v squared. So I'm going to use some perfect square method to rewrite it as v positive 1 the whole squared. If I do that, I get a v squared, I get a 2v, and I get a 1, but I need to get a 2 there. So I've got a v squared, I got a 2v, and I need to get a 1. So just simply add 1. So 2 positive 2v positive v squared is now rewritten as v positive 1 raised to the power 2 positive 1. So place that. So this is going to be v positive 1 raised to the power 2 positive 1, which is equal to dx over x. So now I'm going to be integrating. So integrating both sides, we would get, you can write the word integrating and then follow it up with the word both sides. So when you do that, so this is going to be, okay, let me write the negative half like this. So this is going to be integral of this quantity 2v positive 2 times dv divided by 2 positive 2v positive v squared. This is one integration, followed by negative integral 4 times dv divided by v positive 1 whole squared positive 1. This is the second integration, is equal to dx over x. In fact, I could have moved this 1 over 2 to the right. Okay, so that would have been much better if I would have done that, but it doesn't matter. So let us perform the integration here. So we have got this. Now for this quantity, if I were to take, let 2 positive 2v positive v squared is equal to t, then I would get 2 positive 2 times v times dv is equal to dt. So this quantity can be rewritten as, in place of 2v positive 2 times dv, it's going to be dt, divided by, in place of the denominator, it's going to be t. So this will give me ln t, which can be rewritten as ln of 2v positive v squared. So this is the value for this integration. Now for this, let v positive 1 be equal to some t. So this means dv will be equal to dt. So 4 times this integration, in place of dv it's going to be dt, divided by, in the place of v positive 1 it's going to be t squared positive 1. This is nothing but tan inverse of t, which is rewritten as tan inverse of v positive 1. So you can box this just to show the examiner that you know what you're doing. So rewriting, we get negative 1 over 2. This, in place of this, is going to be ln of 2v positive v squared, negative, in place of this quantity it's going to be tan inverse of v positive 1. Of course there should be a 4 there, okay, because it's 4 times, so this is going to be 4 times tan inverse of v positive 1, so 4 has to be placed there. Now on the right side it's going to be ln of x. Of course you can place ln c also, because since we are having ln everywhere, we can also place a ln there with the constant c. Now rewriting, now multiplying by negative 2 both sides. Okay, when we do that, when we multiply by negative 2 both sides, this is going to become positive. This is going to be positive. So I would have ln of 2v positive v squared, followed by negative 4 times tan inverse of v positive 1 is equal to, since I am multiplying by negative 2, this is going to be negative 2 times ln, see, ln of x into c. See, I'm going to use ln of a plus ln of b, which can be rewritten as ln of ab, right? So by this formula I can rewrite ln x plus ln c as ln x times c. So that's why it's going to be negative 2 times ln xc. So having obtained this expression, I need to now substitute. We know that y is equal to vx, therefore v is equal to y over x. So make the substitution and complete the solution. So this is going to be ln of 2 positive 2 of y over x positive y over x whole squared, negative 4 times tan inverse of y over x positive 1 is equal to, now I can rewrite this as ln x negative so on the right it's going to be negative 2 times ln of xc. Now this can be simplified. Ln of, taking x squared as the LCM, I would have this to be as 2 times x squared positive 2 times x y positive y squared, negative 4 times tan inverse of, this is taking x to be the LCM, this is going to be y positive x divided by x is equal to negative 2 times ln of xc, ln xc. Now I can further rewrite this as ln of 2x squared positive 2xy positive y squared divided by, this is ln of a over b, right? So I can bring this down as ln of x squared negative 4 times tan inverse of x positive y divided by x. Of course, if you want, you can place a modulus sign, followed by negative 2 times ln of xc or ln xc. Okay, so this is rewritten as ln of 2 times x squared positive 2xy positive y squared. Now I have I have got a negative ln x squared here, and I have got a negative 2 times ln x. Okay, so I can actually club these two things together. So let us do that. So this is negative 4 times tan inverse of x positive y divided by x. In fact, you don't need to place the absolute sign, just retain it as it is. So this is equal to negative 2 times ln of xc. Now this becomes positive ln x squared. Now I can rewrite this as negative 2 times ln xc positive 2 times ln xc, which is nothing but ln 2 times ln x negative 2 times ln xc. I can take 2 common and write this as ln x positive ln xc. Okay. Oh, in fact, I can't do this because there's a negative sign there. So this is actually 2 of ln x negative ln xc, which can be rewritten as 2 times of ln x divided by xc. Okay, you are having it something like this. So this is equal to, now if I move the 2 there, it's going to be ln of, see, the x that you see here can be cancelled. So that is going to be giving me 1 over c raised to the power 2, which can simply be taken or written as a ln c, right? This entire constant, this entire thing can be written as a constant, say some kappa. So on the left you would be having ln of 2 times x squared positive 2 times xy positive y squared negative 4 times tan inverse of x positive y divided by x. So this is what you have achieved. In fact, you can simply state kappa is a constant. Okay, and the value of k is equal to ln of 1 over c raised to the power 2. Okay, so this, if you were to see this, this is actually nothing but ln of, you can move the c to the numerator, so you get c power minus 1. There is already there 2 there, so which is nothing but ln of c raised to the power minus 2, which is nothing but negative 2 times ln c. Okay, so kappa can also be represented as negative 2 times ln c. So this is one way, or this is the other way. So this is the final answer to the question.